Good afternoon, guys. My name is Kelvin. I'm from Group 30. And for our project, we chose a data set that contains roughly 38,000 different models of cars. They're sorted by year, and it contains information on these cars, like the size of the car, the fuel type, the engine size, etc. Our goal for this project was to create a program to help the user sift through this giant data set and based on like different search parameters, give them the best car that's the best fit for them. Kind of like a dumbed down version of Carfax. Our program begins in the main script. We begin by calling in the data set, and we saved it to the crap. All right, and take two. Our project starts in the main script. We begin by calling in the data set. We named it new data 1. Now, to make it easier to run and like kind of cut down the amount of cars for the user to sift through, we kind of indexed out all of the cars starting from 2007 going towards 2017, and we named that new data 2. Next, we have a menu that asks, do you need help choosing a car? If you press yes, it runs through the first function in this while loop. If you press no, it simply displays if you change your mind, run the code again, and ends the code there. Now, so if the user selects yes in that menu, it jumps down to this while loop. And the first function in the while loop is the make function. The make function begins by uploading the input, which is the original data set, and it sets all of these variables to 0. This is for a pie chart that will pop up. And so going on here, this will count up each car or each model of each individual maker. So like Ford, Chevrolet, Chrysler, Cadillac, Jeep, GMC, Lincoln. And it'll create a pie chart with that. The subplot is because we have 3 different charts or graphs in here. So that was the easiest way for us to break it up. Then it jumps down to this switch case construct, and depending on what the user selects, it will cut down the data set into only cars of that specific brand. And then finally, it will count all of the cars from your selection and display to you the amount of cars in that selection. All right, the second function that this program calls is the fuel economy versus time function. This function accepts the make table as an input and will output a graph of the fuel economy versus time. It begins by indexing the years column, and then it jumps down to create a table of the years, and then we create a vector where we will store average fuel economy for the given year. Next, this first for loop creates counts up the amount of cars in that year, and then this for loop indexes the average fuel economy, and that's what this does. Now, since this is the second graph in our script, we used the subplot function again and plotted it as second. So then this all just plots it. The hold on is to keep the hold on so that we can end up plotting the third graph later on. Next, so that'll pop up the graph. Now, the next function that is called is the year table function. So this will sort the new table. This will accept the make table as an input and cut it down and output another table called the year table, which contains all of the cars of the specified year by the user. So for this function, it starts with a menu prompt asking which year you're interested. And based on the user input, it jumps down to this switch case structure that will index through the main script or the main table and pull out a smaller table of all of the cars with that year. The next function that gets called is the fuel type function. It accepts the year table as an input and exports the fuel table, which is a more narrowed down table. based on the user input for fuel. It begins by calling up this function, and so the function choose your fuel, which basically just pops up a menu for the user to select their fuel type, and going down to a switch case, and that sets the fuel variable. Then using that, it'll sort through the data to only select data of that selected fuel type, and it inputs that and puts that into its own new table. The next function that's called is the drive function, which uses the fuel table as an input and outputs a drive table, which is a more cut down table based on the user input for the drive function. The drive function begins by popping up a menu asking what kind of drive are you looking for: front wheel drive, rear wheel drive, or all wheel drive. And then based on the user input, it jumps down to a switch case, which will index the different drive types that are available. For the all-wheel drive, there are 4 different variations of all-wheel drive, so I had to add 4 different indexes. But then, so that'll concatenate it. And then this function also will display how many cars match your search, along with displaying the more narrowed down data set called the drive table. The next function is the engine cylinders function. This accepts the drive table as its input and outputs the cylinder table, which is, as you guessed it, another smaller table based on user input. For this function, it begins by popping up a menu on asking the user what engine size they would like: 4-cylinder, 5-cylinder, 6-cylinder, 8-cylinder, and 10-cylinder. Based on that user input, it goes down to a switch case that basically indexes the data set and pulls out those cars that have that specified cylinder type. These 2 if statements down here are for 2 reasons. One, if the user specifies they don't want or they don't care what engine size they want, or if they choose an engine size that is not available, it'll spit them back and loop back to that menu and ask them again. The final function needed for this program to run is the annual fuel cost graph. And it's kind of self-explanatory. It creates a bar graph of the annual fuel cost per year of all of the cars in the selected data set, and then plots it against the ones that the user has selected. So that function is right here. This basically calculates the average for each of the years. This calculates the average of the final table value, so all of the cars selected by the user, and this plots it as the third graph on the subplot. It uses the left axis as the original bar graph for the entire data set, and the right y-axis as the user selected data set. So when you run it, it pops up this menu box asking, do you need help choosing a car? When you press yes, it'll pop up, these are your car brand options, please select one. So let's say we want a Ford. You click Ford. Now it'll take a minute to load up because it's going through another function. Now it pops up the percentage of car brands available for selection. So this is a pie graph showing all of the car brands and how they compare against each other. Now then it pops up the average fuel economy for this brand, and as you can see, it's been going pretty good lately, and it asks, would you like to fit a line in this data? You press yes, should pop up one line right there. Yeah, there's the curve fitted line. Now it asks, would you like to predict fuel economy of a future year? You press yes, it asks to input a year, so we'll do 2020. And then it shows you your predicted fuel economy in the year 2020. If this bar wasn't in the way, I'd read it off. And now it pops up the year function. So it asks, what year are you interested in? Now you can select a year. I'm going to select 2016. And it pops up, 88 cars match your search. Now it asks, what kind of fuel type would you like to use? We can select regular gasoline. And it'll pop up this is just the smaller table, and it shows 85 cars match your search. Now you can narrow it down even more by selecting the drive type. Let's do all-wheel drive. And now we can select the cylinders. So let's do a 10-cylinder. No vehicles in your search criteria have the engine size. Please select another size or no preference. Let's go 6 cylinders. Now it says there are 17 cars that best match your search, and it displays those 17 cars for you. And then here's the narrowed down table function, the final table, that shows the information about each of those cars. And going into this project, I had a pretty good grasp of coding with MATLAB. But this project introduced me to real-life application of MATLAB that I was unaware of. It kind of tied everything together that I learned in this class.